Today's lesson is A2, Arithmetic Sequences and Partial Sums. Now, arithmetic sequence is when we have kind of like an equation that could be like y equals mx plus b, per se, for these types of sequences. It's where we're jumping by a same value or what they would call a common difference between the terms. For example, 3, 7, 11, 15, right? We're jumping by 4s, right? And we're adding or subtracting a value between each term, consecutive term. Now, it's arithmetic specifically when, how can I find that common difference, right? Most people, like I was just saying, 3, 7, 11, with those three terms, you could figure out there's two patterns of plus 4 going on, right? Now, if it's maybe a more difficult number, you could do second term minus first term. And to verify that that is the answer, doing third term minus second term to confirm that those both match, and that would give you the B common difference of the sequence. Now, starting off, determine whether the sequence is arithmetic, and if so, find the common difference. So we have 16, 13, 10, 7. So you're looking at what each jump is. Is there a common jump, right? Minus 3, minus 3, minus 3. Sounds good to me. I would say yes, the common difference is the minus 3. Over here we've got 1, 3/2, 2, 5/2, 3, 7/2. Now, I find there's two different ways that you can recognize a pattern here if you don't see it right off the bat. The way that seems to work for most of these is rewriting the ones that don't have a denominator with a common denominator to the other terms. So rewrite 1 as 2/2, 2 is 4/2, 3 is 6/2. And now let's read it. 2/2, 3/2, 4/2, 5/2, 6/2, 7/2. Okay, bottom is staying as 2, and we're increasing by 1, right? 2, 3, 4, 5, 6, 7. So yes, difference is 1/2. Over here we got 2, 6, 18, 54. And if I go 2, 6, and then 18, 54, clearly those jumps aren't the same. I would say no right away. But first we've got a plus 4, then we've got a plus 12. Those don't match, and this is going to be a times 3, which is not a common difference. So we're just going to say no. So moving on, our explicit formula for arithmetic sequence is a sub n equals d times n plus a sub 1 minus d. Now, what we like to do is say, okay, the nth term, right, that's what the explicit formula is giving us, equals the common difference times n, that variable is going to stay there, plus the first term minus one common difference. And why is that? So, again, we'll just make one up real quick. That 3, 7, 11, right? And now we can quick see that the difference is plus 4, right? So d is 4, positive 4. And if we plug that into the formula quick, a sub n equals, we added 4, so 4n, but how do we know where we start at, right? Well, we already have, like, our first term. This is considered the first term, but we didn't really add 4 to get here, right? So if I plug it in, I've got 4 plus what's going to get me 3, right? So that is why this piece is a sub 1 minus d. A sub 1 stands for the first term. And again, d, as I already told you, is common difference. So again, if we piece this together, it would basically be one term backwards, is another way to think about it. Minus 4 from 3 to get minus 1. And then if we plug in 1, test it out. 4 times 1, 4, minus 1 is 3. Oh, what do you know? It works. That's why. Because they count a jump before we've even done a jump. That's why we have to go backwards 1 here. So you can either take the original and subtract, do an opposite jump, like subtract the common difference 1 more to get our term here. Some people call it a sub 0. Or you can just plug it into the formula. That's how I will work most of these problems. So find the explicit formula of the arithmetic sequence and starts at 1, find the given term. So I see 3, 1, -1, -3, -5. Okay, so it looks like we're subtract 2, subtract 2, subtract 2, subtract 2. And again, reminder, 3 is a sub 1, and I'm seeing the minus 2 pattern here, so minus 2 is my common difference. And now I'm ready to plug it in. So if a sub 1 is 3, we've got a sub n is -2n plus first term, a sub 1, minus one more common difference, so minus a negative 2. Well, this is a double negative, so we're adding 2, right? We're doing a jump one more the other direction, right? If you're going the other way, plus 2, plus 2, plus 2, plus 2, we would start at 5, right? 5 would be our term before the first term. And so when you do this math, 3 plus 2 is 5, and we get negative 2 plus 5 is the formula. Plug it in, just do one or two terms. Negative 2 times 1 plus 5 is 5 minus 2 is 3. Check, it worked. 5 minus 4, which n is 2, is 1. Yep, it works. And then finding the 21st term, plug in 21, we get negative 42 plus 5 is going to give me negative 37. Now, clearly we're going to find a sub n before we look for a21. Do not spend your time doing common differences 20 more times to get here. Sometimes I'll even make it larger number than this just so that you get the idea that we're not supposed to be doing this 20 times, right? Find the pattern, plug 21 in for n in the pattern, and make sure it works. I would definitely recommend, if this was a problem on a test or quiz, to double check that it works with the given before plugging in 21. Next, 15 fourths, 9 half, 21 fourths, 6, 27 fourths. Oh boy, man, we got 3 different denominators. So I'm going to make a common denominator of 4. So, because it's hard to see. Well, minus 6 plus 12, all of a sudden we're 6. And then, right, so it's hard to see, and the mixed up denominators mess that up. So this is going to be rewritten as 18 fourths. This will be written as 24 fourths. And then we'll look at the pattern. So 15 to 18 to 21 to 24 to 27. Sounds like we're jumping by 3's, and the denominator is not changing, so we're adding 3 fourths. And they just simplify when it happens to simplify. So the common difference is 3 fourths. Subtracting 3 fourths, I like to go backwards a term here. 15 minus 3 is 12 fourths, which would be 3. So in my head, I already have 3 fourths n plus 3. I'm going to work it out with the formula here. dn plus a sub 1 minus d is going to give us 3 fourths n plus 15 fourths minus 3 fourths, which gives us 12 fourths, which is 3. And now plugging in our 13th term, 13 times 3 fourths plus 12 fourths, right? Notice I rewrote it as 12 fourths for the purpose of making it easier to add. 39 plus 12 is 51, and 51 fourths is our 13th term. Next, we've got a recursive sequence here. The first term is 15, and ak plus 1 equals a sub k plus 9. I highly recommend writing out 2 or 3 terms to kind of see what the pattern is. Is plus 9 just all we need, or do we need to see the pattern? So, plug in the pattern. Second term, 9 plus 15 is going to be 24. Third pattern, 9 plus 24, 33. Sorry, third term. So I've got 15, 24, 33. Sounds like a plus 9 pattern. So, right, there we go. Plus 9 is our common difference. So when we have this, it's typically going to be this value here in a recursive sequence. And so, a recursive formula, pardon me. And so now we've got this, and then we're going to go backwards 9. 15 minus 9 gives us 6. Or we can plug it in this way, 15 minus 9, first term minus the common difference, will also get us 9n plus 6. And we want the 12th term. So 108 plus 6 is 114 for that 12th term. One more of these before we get to our next topic. We've got the second term is minus 2, and the fourth term is 12. So how are we going to figure this out, right? How are you going to figure it out when we've got kind of 2, not necessarily right and early terms, okay? So what you're going to do is treat it like, right, as I mentioned before, kind of like y equals mx plus b. We're jumping by a same value each time. So I could technically write out blank, comma, minus 2, comma, blank, comma, 12, and try to look at that and figure out the jumps that way. However, you can actually use slope. Treat this as if it's a point. When x is 4, y is 12. When x is 2, y is negative 2, right? And then we can do the slope of this to solve. So 12 minus negative 2 over 4 minus 2, and that will give us 14 over 2, which is 7. And now we take that common difference, and I'm going 7 backwards from here. Negative 2 minus 7 gives us minus 9. And so there's our first term. Now we need the first term to find the formula. Right now, also, what we could have done is thought about the a sub n equals nd plus a sub 1 minus d, right? Now think about that just for a second. If we wrote out that whole thing, what do we have, right? If we called this the second term, right, because we have that up here, and then we know n is 2, so 2 times common difference 7, plus a sub 1 minus d, which we still know is 7, what variable's in that equation? Just that one. We already know, like here's our one variable. I shouldn't check mark both, but I want to redo that one. But this is what we're solving for here. And we already know a sub 2 is minus 2, and you can plug it in and solve. So that's what I'll do down here just to show you that other method. A sub 2 is minus 2, and that will equal 7 times 2, I did d times n this time, plus a sub 1 minus 7. And then 7 times 2 is 14. 14 minus 7 is 7. Subtract 7 from both sides, I get minus 9 for first term. And then jumping one more back, I get minus 16. And so I'm going to get 7n minus 16. You could also use this formula once I figured it was minus 9. And that will still get us to right here. And now 15th term. So 15 times 7 is 105. Minus 16 sounds like 89. And there is that. Okay. Next, the sum of a finite arithmetic sequence. Okay. What we're talking about here is it's saying, let's, giving you the pattern that going back to the old 3, 7, 11, 15, 19, 23, etc. Right? Say I'd say, given that pattern, find me the first 15 terms, right? That would be a partial sum. And what we have is a pattern here, right? Because if you ever recall, there was, I think, a story of some mathematician who was really bright early on, and one of his teachers, wanting just to keep him busy, said, add the numbers 1 through 100 together and tell me what you get. And he basically figured out this formula in his head, right? Well, first and last numbers are going to add to equal the same as the second and the second to last numbers, right? 1 plus 100 equals 2 plus 99 equals 3 plus 98, right? Those are all going to add up. Same thing works with sequences that aren't just plus 1 minus 1, right? And how many pairs do we have? This is why we have n divided by 2 pairs, right? Because we have two numbers become 1, and they're going to match the first term plus the last term. And some people might say, well, what if it wasn't an even number? That's the point. If it wasn't an even number, then we would get half of this would be the middle term, right? So for some reason, if that 1 through 100, right, I didn't have a nice number of terms, 50 would be left over, right? If that was the case, but it wouldn't happen. So formula, n over 2 times a sub 1 plus a sub n. So find the partial sum of the arithmetic sequence, and we want the first 12 terms. So we got 4, 16, 28, 40. I'm seeing a plus 12 pattern going on here. Okay, and then I go backwards 1, 4 minus 12 to get me 8. So I like to figure out what is my formula first, because I need the first term, the 12th term, right? I need n divided by 2 times a sub 1 plus a sub n, right? So I need the 12th term, I need the first term, a sub 1, and I need n. Well, n is 12, right? So we got 1. Find the formula here that I just kind of spoke out loud. We're at plus 12, minus 12 from 4 to get minus 8. And now I need to find the 12th term, right? First term is 4, I see right there. 12th term is 144 minus 8, which is 136. So now 136 plus 4 will equal the same as the second number and the 11th term, right? So when we plug that in, we've got 12n, which is 12, over 2 times first term plus last term, 4 plus 136. So we've got 6 groups of 140, which is 840. And there's a formula up top, just in case you were needing to rewrite it down and didn't write it down last slide. Next, we can have summation notation here. Now, notice we're going from term 3 to 42. So does the formula still work? Yes, but we're not using the first term because the first term's not in this, right? The third term. So we're going to be doing n over 2 times the third term in this case, and then times the 42nd term. But n is going to be a different number. N is not 42 because we don't have 42 terms. So a little extra math here, right? The general form for finding how many numbers this is top number minus bottom number, subtract, and then add 1 back. right? Just like if I told you to do problems 3 through 42 on the homework. Some people would say, okay, 42 minus 3, 39 problems. Now, you subtracted problem 3, and I told you to do problem 3. Right, so that's why you subtract 2 technically, but the general way to say it is just, subtract as is, and then add the first one back. So that's why 42 minus 3, 39 plus 1, n is 40. Now I'm still plugging 42 in, but we've got a sub 3 is negative 5 times 3 plus 3 is negative 12. Plug it in. A sub 42, same thing. Negative 5 times 42, so negative 210 plus 3 is negative 207. Add these together, and we have 40 over 2 pairs. So 20 times negative 219 is going to be something like 43,800 or negative 4,380. It was 10 off. Negative 4,380. And next, 1 through 100 of the terms of 7n minus 50. So 100 minus 1, like when we start at 1, you can just take the top number, right? But last time it started at 3, so we needed that funky equation. Just in case you want to test it out, 100 minus 1 plus 1 is 100, right? Minus 1 plus 1 cancels. So n is 100. First term is 7 minus 50 is 43. 100th term is 700 minus 50 is 650. And so 100 pairs, 100 divided by 2 gives you 50 pairs of negative 43 plus 650, which is 607. Give you something like 30,350. And there it is. Again, feel free to use your calculator on those, for sure. Last one, kind of giving us a third term is minus 2, the 11th term is minus 42. Find the first 15 sum of the first 15 terms. So there's a couple ways to do this. How I like to do it is, again, based on what we're given, it is wise to use that slope formula, right? The common difference is negative 42 minus a negative 2 over 11 minus 3. So 8 jumps is what's happening here, and the total of the 8 jumps gives us negative 42 plus 2 is negative 40. So negative 40 for 8 jumps is really minus 5 per jump. Okay, so common difference. Go another minus, going the other way, so plus 5, I get, I believe 8 is our first term. That's what I'm saying here, plus 5 from that minus 2, and I get 8 as our first term. And then 3 was our second term, but it doesn't matter. Just a quick way to think about it, right? If you think about just the terms as blanks, or you could have done a sub n is negative 5n plus a sub 1 minus a negative 5, and then plug in either a3 or a11 into this. Just remember that if it's a11, n is 11. If it's a3, n is 3. So I plugged in a3 to get negative 2 equals negative 5 times 3, or minus 15, plus a sub 1 plus 5 because it's double negative. So negative 15 plus 5 is minus 10. And then I'm going to plus 10 to both sides to get 8. So next, plugging into the formula, a sub n equals negative 5n plus 8 minus an d, which is minus a negative 5. So 8 plus 5 is 13, right? Because if we took that 8 and added another 5 going the opposite way, you get 13. And now we need to find the 15th term. 15 is negative 75 plus 13 is negative 62. Plugging into the formula, we've got 15 halves of 8 plus minus 62, or negative 54. So 15 halves of negative 54 is negative 405. That wraps up today's lesson. Feel free to email if you have any questions or comments. Concern.